Welcome back to my YouTube channel. My name is Mohammad Ubaid and this is another video of basics of structural analysis series. And today in this video we are going to solve a very interesting problem in which we have a prop cantilever with an internal hinge, and we also have a concentrated moment applied at point C. So in this problem, we are going to find out the slope at B and deflection at B by using moment area method. If you are new to our channel, please subscribe to our channel and share this video. If you have any confusion regarding any point in this video, please comment down in the comment box and I will try to answer all your comment as soon as possible. So let's get started with the solution of this. So this is our problem, and before starting the solution, let us refresh our concept about internal hinge. Okay, because we have to find out the slope and deflection at internal hinge. So first of all, let us understand how the internal hinge deflect. So let us assume that this is our point B. If under loading, the internal hinge is deflecting like this. Okay, and this is some random horizontal line for reference. Okay, so as I have told you, for finding the slope at any point, we have to draw the tangent at that point. Okay, so in this deflected shape, you can see that we can draw two tangent. We can draw two tangent for finding the slope. One tangent is this, and the other tangent can be drawn from this direction like this. Okay, so in this way, for internal hinge, we can have two slopes. Okay, we can have two slopes which we will call as theta b, right, and this slope will call as theta b left. Okay, and the deflection will remain same and we will call it as theta b. Okay, so the important point which we have to remember is that for an internal hinge we have to find two slopes, theta b right and theta b left. Okay, because the internal hinge, for internal hinge, these two slopes can be different. Okay, these two slopes can be different. Okay, and these two slopes can be different, so that's why we have to find these two slopes separately, and the deflection will remain same, only the slope will be different. Okay, so this is the important point about this problem. So we have understood the basic point which we have to find. Now let us proceed for our bending moment diagram, which we usually draw for solving any problem by using moment area method. Okay, so when we have a beam in which we have an internal hinge, how we draw the bending moment diagram of that beam, it is very important, and we will see how we draw. So for solving this type of problem, we separate the beam at internal hinge. Okay, so in this beam we have an internal hinge at B, so we can separate these two portion. What are these two portion? AB and BC. We can separate these two segment of the beam, and we can find out the reaction at B, and then we will draw the bending moment diagram. So let's see how we will solve this problem. Okay, so first let us draw the free BMD diagram for both the section of the beam. So if I separate the section BC from section AB, so it will look like this. This is the concentrated moment which is working on the support C, and there we have internal hinge. So as I have separated this BC portion, so there must be some reaction applied under which the beam will remain in equilibrium. Okay, and the other portion of the beam is this. Okay, so here we have 25 kilonewton of load, and this is our free end A. So there we have reaction in downward direction, so for equilibrium there must be a reaction in upward direction for equilibrium at B. Okay, did you understand my concept, what I want to say? So in this way we can separate these two beam, and we can solve our problem very easily. So this is our 12 meter, and here we have 10 meter, and here we also have 10 meter. Okay, I have drawn the free body diagram of these two separated segment of the beam. Now let us find the RB and RC for this BC portion. So let me draw it again here. So this is our support C, which is a pin support, and here we have 48 kilonewton meter of concentrated moment, and this is our point B, and we have considered the direction of RB like this. Okay, so and we have considered the direction of RC as this, and this is our 12 meter. Now applying the equation sigma MC is equal to 0 and taking clockwise direction as positive. Okay, so from this FBD we can see that 48 will be taken as positive and we will take RB times 12 as negative because it is working in anti-clockwise direction and it will be equal to 0. So from here we can see that RB will be uh, 4 kilonewton. Okay, and by using sigma Fy is equal to 0, sum of forces in vertical direction equal to 0, and we will take upward direction as positive, and as the direction of RB is downward, so it will be minus 4, which is our RB, and RC will be taken as positive. So from here you can see that the value of RC will be 4 kilonewton. Okay, so we have found out the value of RB and RC very easily. Now we will take the portion AB and we will find out the other values. Okay, or we don't have any need for finding other value because this RB will be equal to this RB, okay, for the equilibrium, and these RB and RC are sufficient to draw the bending moment diagram of this particular beam. Okay, so let us see how we will draw the bending moment diagram. So we have found out the value of RC at C. Now we want to draw the bending moment diagram of this beam. Okay, so we can draw the bending moment diagram separately for AB and BC portion, because after separating these two portions, this beam has become uh, very easy, and we can draw the bending moment diagram very easily for these two separate portions. Okay, so if I want to draw the bending moment diagram for this BC portion, so let me take this BC portion first. Okay, so this is our BC. Now what is the moment at C? So what is the value of MC? So M at MC we have a concentrated moment, and this concentrated moment is producing hogging, okay, in this portion BC. So we will take this as minus 48 kilonewton meter. Okay, and what is the value of moment at MB? Okay, so we have minus 48 for due to concentrated moment, and at any section, let me take any section as at distance x from C. At any section x, we will have, let me write it as 4x. What is 4? 4 is the reaction at C. Okay, because this reaction will produce sagging moment, so we will consider it as positive. Now for we will take x as 12 because we want to find the bending moment at B, so this x will be 12. Okay, so here you can see it will be 48 plus 48, so MB will be equal to 0. Okay, so we can draw it like this. So here it will be minus 48 kilonewton meter. Okay, and at B it will be 0. Okay, as we usually do, we divide it by EI to change it in to change it to M by EI diagram. Okay, now let us draw the bending moment diagram for the remaining portion of the beam. So this is our AB. So at B we have a reaction of 4 kilonewton. So if I just calculate the moment at, let me say this point as E. Okay, so we have at B 4 kilonewton of reaction. Okay, so it will be 4 times 10, which will be 40. So it will go something like this. So this will be 40, and this will be 40 upon EI. Okay, this will be in continuation with this line. Okay, and what will be the value of MA? You can see this figure. You can see this figure. Okay, so from this figure you can understand very easily. So what will be the value of, let me name this point as E. So what will be the value of ME? So ME will be RB times 10 minus, sorry, it will not be, minus 25 will not be taken here. Okay, so it will be RB is 4 times 10, so it will be 40 kilonewton meter. Okay, so in the same way we can find out the value of MA. So MA will be 40 times 20, the whole distance from B to A, and minus 25 into 10. Okay, so after solving it will come out to be minus 170 by minus 170, sorry, minus 170 kilonewton meter. Okay, so we have found out the value of moment at ME and MA. Okay, now let us draw the bending moment diagram. Okay, so we have found out the value of ME as 40, and we have found out the value of MA as minus 170 kilonewton. After dividing by EI, it will convert to the M by EI diagram. So this is the shape of our BMD or M by EI diagram. Okay, so it is our M by EI diagram. Okay, now this is minus, this is positive, this is again minus. Okay, so in this way you can draw the bending moment diagram for this beam. Okay, we have drawn the we have drawn the bending moment diagram or M by EI diagram for this beam. Now let us draw the deflected shape for this beam. So and this is our undeflected shape of this beam, and this is our fixed end, and this is B where the internal hinge is located in this beam, and this is our C, and this is A. So after deflection this beam will look like something this. Okay, so there will be no slope at fixed end, so it will look like this. Now as I have told you earlier that there will be two tangents, so let us draw those tangents. So this is, let's say, tangent 1, and the other tangent will be here. So this tangent will be like this. Okay, so this will be our theta B right, and this will be our theta B left. Okay, now the point is how we will find these two theta B. Okay, so this will be our YB. Now as we have drawn the bending moment diagram by separating these two beams, so we can see here that this portion of this beam which looks like cantilever, so this is B dash and this is A. We can see here that we can apply very simple formula which we have used many times, theta B over A by AM by EI, and from here we know that it will be theta B over A minus will be equal to theta B minus theta A is equal to AM by EI, and we know that theta A is 0 because it is a fixed end. So from here we can find out theta BL very easily. Sorry, let me write it again so there should not be any confusion. It is theta BL. Why it is theta BL? Because as I have drawn in this figure that this slope, okay, this slope I have drawn it as theta BL because this is tangent at A, or you can say this is A. So if I draw a tangent, so let me say this is tan A. Okay, so this, the slope of tangent at A is 0, so this entire slope will be equal to theta B at B. Okay, so as it we know from geometry that these two theta will be equal, so this theta B will be equal to this theta BL. Okay, so from here we can find out the value of theta BL very easily, and all we want is the area of the bending M by EI diagram between A and B, which we can calculate from our figures from our M by EI diagram very easily. So let us find this area. So I am drawing the bending moment diagram again here for convenience for portion AB. Okay, so this is our B and this is A, and here the value was minus 170 upon EI, and in at somewhere point it was 40 upon EI. Okay, so it will meet this point somewhere here. Okay, and we don't know what is this value. Okay, we don't know this value, and the total length of beam from A to B is 20 meters, so it will be, or let me not write it like this. So this is our 10 meter. So this remaining length will be, what will be this length? So this length will be 10 minus x. Okay, this length will be 10 minus x, and we have called this point as E. Okay, so first of all we have to find this x, because for finding this area we need the area of this triangle and we need the area of this triangle. Okay, so for finding this x we will use similar triangle property. So from similar triangle we can write as 170 upon x is equal to 40 upon 10 minus x. From here we will get the value of x is 8.09 meters. Okay, now we can find the value of am very easily. So am will be equal to 1 by 2 minus 170 upon ei for this triangle, and multiplied by x, and x is 8.09 for bracket, and plus 1 by 2 into 40 upon ei multiplied by, and this value will be 10 plus 10 minus 8.09. Okay, so after calculation you will find this value to be, sorry, it will be a upon ei because we are considering ei. So this value will be, I am writing the value here, so it will be minus 449.65 upon ei, and this is equal to theta bl. Okay, okay, we have found out the value of theta b left. Now two parameters have left which we have to find out are theta b right and yb. Okay, yb can be find out very easily, as we can see here that if I find the value of tb over a, if I find the value of tb over a, so this will be equal to yb. Okay, from, because from the geometry this will be our tb over a. Okay, tangential division at b with respect to the tangent drawn at a, and as I have shown you here that the tangent at A is horizontal, so it will be our YB. Okay, it will be our YB. So for finding TB over A, for finding TB over A, let me write the formula for TB over A here. So this is our TB over A. It will be equal to AM x bar upon EI. Okay, and we can calculate the value of AM upon x bar from this figure, and we have to multiply it by x bar. What is x bar? X bar is the distance of the CG of this triangle from the point B, because we are calculating the deflection at B. Okay, now let us put the values and calculate what we will get. So the value of, let us take this triangle first. Okay, so it will be 1 by 2 minus 170 by EI into 8.09. Okay, multiply by the distance of CG. So this value, okay, this value, if I calculate this value 10 minus x, so it will be about 1.9 meter. Okay, so this value will be equal to 10 plus 1.9, and it will be 11.9. Okay, and this is the triangle which we are considering right now. So the CG of this triangle will lie somewhere here. Okay, the CG of this triangle will lie somewhere here, and this distance will be equal to, this is x, which, what is the value of x? X is 8.093 by 3 multiplied by 2. Okay, 2 by 3 times the base of the triangle. Okay, so this is our first triangle. Now let us consider our second triangle. Okay, so the area of second triangle will be 40 upon ei multiplied by 11.9. Okay, the total length of the base, and the CG can be calculated by directly using this formula 11.9 upon 3. Okay, don't, if you don't remember the formula, let me refresh your concept. So if we have a triangle like this, okay, and this is our H, this is our total H, and this is A, from here to here, and I want to find out the CG from this end. I want to find out the CG from this end. So the value of x bar will be a plus h upon 3. Okay, the value of x bar will be a plus h upon 3. So from here we have wrote down this equation. Okay, after calculating these values we will get TB over A as minus 10154.36 by EI. Okay, so now we have got the value of TB over A. So this value will also be equal to YB. Okay, now we have found out the deflection at B in a very simple manner. Okay, so the only parameter which I have left now is theta B right. Okay, so what will be the value of theta B right? Now let me just increase this length of this tangent. Okay, so from here let me erase this YB also. So from here, can you see how we will approach for this problem? So this is our, let me draw it here. So what is this? This value which we have found out right now, this is YB. Okay, this is our point C, and if I want to find this value, what is this? This is TC over B. This is TC over B. Okay, because what is this? This is tangent. This is tangent. What is it? This is tangent drawn at B, and this is our point B, and I want to find out the tangential division at C. So this will be our TC over B, tangential division at C with respect to the tangent drawn at B. So, and if let me draw it separately, or let me erase this portion so you can understand this very easily. Okay, so if I just, let me name this as B dash. So if I see this triangle B dash, and let me name it as F. So if I just see this triangle, so this is F, and here it is theta B, right? And here we have this value YB, and this is TC over B, and this whole length is 12 meter. So can you see, from this triangle we can find out the value of theta B r very easily. So what we have to do, we have just to find out the TC over B, and we will add this TC over B to YB, and then we will divide it by 12, so we will get the value of theta B r. Okay, so now I think you have understood this very clearly. So let me find out the value of TC over B. Okay, so for the portion of TC over B, we will take this value. So this is, sorry, this is B and this is B. We only need this area of diagram, this area of M by EI diagram, and this value is minus 48 upon EI, and this length is a total 12 meter, and this is minus. Okay, so for finding the value of TC over B, we have to use the formula AM x bar upon EI, and what is the value of area? So it will be minus 48 upon EI times 12, and what is the value of x bar? Because we are finding the deflection at C, so we will have to consider the x bar from C. Okay, remember. So it will be 12, sorry, it will be 12 by 3. Okay, so after calculating, this value will come out to be minus 1152 by EI. Okay, so as I have drawn in this triangle, or as I have drawn in this triangle, or you can see from the this main deflected figure, that theta BR will be equal to TC over B plus YB upon 12. Okay, so let me just put the values. So theta B R will be equal to TC over B plus YB upon 12. Okay, and we have calculated the value of, and we have calculated the value of TC over B. It is minus 1152 by EI, and we have also calculated the deflection, and the deflection was minus 1014.36 by EI. Okay, and divided by 12. whole divided by 12. So after calculating, this theta BR will come out to be about minus 942.19 by EI. Okay, so in this way we will find out the value of theta BR and theta B left and the deflection at B. I hope you have understood this problem very clearly. So thanks for watching. We will meet in our next video.